Hi everyone, so today we're going to be solving three-step equations. So solving multi-step equations with variables on both sides. So that's really another title that we can use. Sometimes they're called three-step, sometimes they're called multi-step. So in this case, it is a multi-step equation, but it only requires three steps to solve. So here we have 5y minus 3 equals 3y plus 5. So you can see here, this is different than the other equations that we've solved in the past because it has variables on both sides of the equal sign. So when we're solving equations like this, the first step, and this is really a suggested step, doesn't really have to be the first step, but it's highly suggested because it'll help you get rid of negatives in the future. But we're going to move the variable with the smaller coefficient. Remember, coefficient means the number in front of the variable. Variable is the letter that represents the unknown number. So here we have 5y and we have 3y. So 3y is the term with the smaller coefficient. So first, before I even do that, we're going to draw those train tracks. Make sure they actually look like train tracks. And do it like this. Okay. So we're going to move that variable. We're going to move that 3y. And it's a positive 3y. There's no negative in front of it. So we are going to subtract it on both sides. Now we're going to subtract it from its like term. I want to be able to subtract it. So I'm not going to put it under this minus 3 because 3y and 3 are not like terms. I'm going to subtract it from the 5y. Very important. Okay, so here, that's going to cancel out over here, which is exactly what we wanted. And then 5y minus 3y over here gives us 2y. I'm going to bring down anything we didn't use, so that includes that 3. This 3 over here, this equal sign, and then this positive 5. So now we just have a two-step equation. So all we did was move that variable because we want to condense the variables. We don't want to have multiple variables. We only want to have one variable. So our second step is to balance the equation and move the constant to the other side. So a cool way to think of three-step equations is like a scale. So if you take something from one side of the scale, now you're going to have to take something from the other side of the scale. And we're going to just use those inverse operations to isolate this variable, and we're going to move that minus 3 to the other side. We're going to do the inverse of minus 3, which is plus 3. So we're going to add that to both sides. These 3's cancel. We're going to get 2y equals 5 plus 3 gives us 8. And then our last step is just solve using inverse operations, which is what we have been doing. We're going to divide by 2 on both sides. And we get y equals 8 divided by 2 is 4. Okay, so we just moved the variable with the smaller coefficient, and that just brought us to a two-step equation, which hopefully you are familiar with. And we just move the constant and make sure we isolate the variable. Let's look at another example. So here we have negative 6x plus 5 equals 4x minus 15. Start off by drawing your train tracks and identify which variable term has the smaller coefficient. So we have negative 6x and we have 4x. So remember, negative numbers are smaller than positive numbers in any scenario. So the smaller variable here is this negative 6x. Negative 6 is smaller than 4. So we're going to focus on moving this negative 6x. So negative 6x, the opposite is positive 6x. So I'm going to add 6x to both sides. And remember to line it up underneath its like term. We don't want to put it underneath this minus 15 because then we wouldn't be able to add them. The goal is to condense, not to make more confusion. So now these 6x's cancel out. Bring down your 5. Bring down your equal sign. 4x plus 6x gives us 10x. and then we're just going to bring down that minus 15, which now we have a two-step equation and we're going to solve like we have been solving. So I'm going to add the 15 on both sides because remember we want to get stuff away from the x. We don't want to bring more stuff to the x. These cancel. 5 plus 15 gives us 20. And then I'm going to bring down this 10x. Now let's isolate that x. Divide by 10 on both sides. Those cancel and we get 2 equals x. Okay, let's take a look at one more example. 13 minus 4x equals 1 minus x. So let's start off by drawing those train tracks and identifying the smaller coefficient. So we have negative 4x here and a negative, if you want to, you can write it in, negative 1x here. So remember, the bigger the number when it's negative, the smaller it actually is. So negative 4 is smaller than negative 1. So this is the term that I want to move, is this negative 4x. So I'm going to add the 4x on both sides, and I'm going to add it to what would be its like term, which is that negative 1x. So now these cancel, and we're left with 13 equals 1. Negative 1 plus 4 gives us positive 3x. Okay, let's isolate that variable even further by moving that constant. Remember the number without the variable. These cancel. 13 minus 1 is 12. We get 12 equals 3x. Now let's divide by 3 on both sides. We get 4 equals x. Okay, because those cancel. So x is equal to 4. Now I want to do this example again. I'm going to do a different process though. So I'm going to erase what we have, but we know that our answer is equal to 4. But I'm going to start it in a different way because this is a multi-step equation and there really are multiple ways to approach it. So I don't want you to think that there is always only one way to solve an equation. Like I said in the beginning, this is really the suggested way. So say for some reason you wanted to move this x instead of this negative 4x, right? Which is fine. So what we can do is add x to both sides. These cancel. I'm going to bring down the 13. And then negative 4x plus, remember we have that 1 in front, plus 1x gives us negative 3x equals 1. Okay, so now let's isolate that. Let's get closer to isolating that variable, and we're going to move the constant. Remember, if we take something from one side, then we want to take something from the other side. So I'm going to subtract 13 on both sides. So now we get negative 3x is equal to 1 minus 13 is negative 12. So we just have more negatives in this case, but we're still doing the same process. We're still using inverse operations. So now we just want to divide, and we're going to divide by negative 3 because that is what's being multiplied to x. Those cancel out, and we get x equals negative 12 divided by negative 3 is a positive 4, just like what we had before. It was just in this form, which is the same exact thing. 4 equals x, x equals 4, it's the same thing. So there's really multiple ways that you can approach these questions, but when we were solving it this way, we weren't dealing with as many negative numbers. And we know that that can be the cause of some confusion for some students and just for some people in general. So avoiding the negatives is a really great way to start, but like I said, there really are multiple ways that you can approach these kinds of questions.